All right, welcome to Algebra 2, Unit 3, Lesson 1 on relations and functions. This is our first lesson for Unit 3. So let's go ahead and get started. This is all about functions, relations, domain, range, all the stuff you guys have heard about before, but let's go through this, okay? Really quickly, you might want to write this down here. A relation, okay, it has no correlation between two things, such as, hair color and weather, okay? Relation is just simply a set of ordered pairs, okay? And you can just get these and just plot them on your map on the coordinate plane. Okay, and the domain, okay, is simply all the x values, all the x coordinates in the relation, or all the x values in the set of ordered pairs. Okay, the domain is also considered or called the input or the independent variable. Okay, and the range is called the output, the dependent variable, and it's simply just a list of all the y coordinates within it. Okay? One way of finding out if a set of ordered pairs or a relation is a function or not is going ahead and doing a couple of things here. Okay, we can go ahead and put it on a graph. Once you put it on a graph, you can use this thing called a vertical line test. If you take a vertical line and it hits 2 points like it does right here, at this point and this point, you can say it's not a function. Okay, if I have a mapping, which is, you have these two bubbles here, and you go ahead and draw the lines from 2 to 3 because that's what it is, 2 to 3 right there. Okay. Negative 1, 1, negative 1, 1, and then negative 1, negative 3. You see how this one input has two outputs? Okay, that can't happen. You can't put the number negative 1 into a function and then spit out two different answers. That simply doesn't happen, so this is actually not a function. Okay, and looking at a table right here, same thing. Okay, you put in the number 1 into the function, you got the answer 1. Put in the number 1 again into the function, and this time you got a different answer. Obviously that doesn't make any sense. So based on the table, look for this. If you have the same x value inputted twice and you have two different answers, it's also not a function. Okay. Now many times students have asked, well, can all the arrows point to one thing? Sure. You can have the number 1, 2, 3, and they all point to the number 0. This would be a function like y equals 0x. You can put in anything you want for x, okay, but 0 times anything is always 0. You can answer a question like this. All right. So moving on to the next page for your notes. Okay. Determine if it's a function or a relation. Well, again, quickly look across the x values, 0, negative 2, 3. If the x values do not repeat, you can go ahead and assume that it's a function. Okay. And it says state the domain. Again, you write the letter D, you start your brackets, and domain is simply just the list of all the x values. 0, negative 2, 3. 0, negative 2, 3. Range, again, you just write the letter R to denote that's the range. Okay, start your brackets, and go ahead and put 1, 4, and 5. 1, 4, and 5. There. Okay. This one right here, you can check it out, see if it's a function or relation. Simply check out all the x values. 2, negative 1, negative 1. Okay, I've got two x values repeating. Let me double check. Okay, when I put this x value in, I got a 1. When I put this x value in, I got a negative 3. Obviously, you cannot have two different y values, so this is a relation and not a function. And again, the domain is simply stating all the x's. Okay, 2, negative 1, negative 1. The range is simply stating all the y's. 3, 1, negative 3. 3, 1, negative 3. Okay. If I asked you guys, look at this mapping right here. Okay, we've got these. 5, negative 5 corresponds to 9. 2 to 0, 3 to 0, negative 1 to 8. Okay, it is a function because none of the input or the domain values have two different y value or range answers. Okay, so look at this. Okay, and we'll figure out what values, what domain and range it could be. Okay, for this one, I'm not restricted to anything. I can put in any value of x that I feel like. So I can say the domain is all real numbers. Okay, and if I put in all real numbers, that means I'm going to get a set of all real number answers for the range. Over here, I can put in any value of x that I want, but the answer, no matter what value of x I put in there, is always going to be 4. So the domain is all real numbers. However, the range is just restricted to the number 4. Okay, this is a horizontal line. Over here, the domain for this one, well, let me see, can I put in any number that I feel like? Well, actually, no, I can't. It says the only thing I can put in for x is negative 2, so the domain is restricted to negative 2. And this the range is going to be all real numbers. This is an example of a vertical line, so it goes up as high as you want it and low as you want it, which is what the range is. The range is all the y's, but it's always going to be at -2. Okay? Using the vertical line test, we can tell if this is a function or not a function. Okay? This is a very easy test. You simply take your ruler, ID card, whatever it is, and we're going to focus on this one here, just work it across and see if you hit 2 points at the same time. Well, on graph number 1, I don't hit 2 points, so it is a function. Okay, let's check out graph number 2. And right away, you can see I hit 3 points here. Okay, I hit 2 here, so this is not a function. Okay, this one, just walk it across. Okay, and you see that I don't hit more than 1 point, so that is a function. Moving along, okay, this U-looking thing right here, walk it across, and still, at all points, I'm only hitting 1 point on that graph, so it is a function. Okay. The circle over here, well, I hit 1 point here, that seems to be working, but the moment I get in there, I hit 2 points all along, and again hit 1 point. So this is not a function. Look at this one. Okay, that's an open dot. Well, look at this. I hit a solid dot and open dot. You would normally think that's not a function, but however, this says that for this lower part of the function, it does not include that number, and for the top part it does. So you're technically only hitting 1 point, so this is a function. On to the next page. And again, feel free to pause the video at any time to go ahead and write these things down. Okay, function notation. This is something that has thrown students for a loop for quite a bit of time. What is this f of x, g of x, and h of x? What do they mean? I've been using the letter y for the longest time, and all of a sudden I see f of x, g of x. All f of x, g of x, and h of x, or any variable that you want to put in there, it just tells you, it just gives you a little bit more of a description of what it is. This could be the function for fire department. This could be the function for gardening, and this could be the function for, like, let's say, Homeland Security. And it really doesn't make a difference. All you're doing is simply replacing the letter y with one of these symbols, and it just tells you what you put into the equation and what your answer is. Okay, so take a moment to read this on your notes, and let's go ahead and work down here. Okay, this says find f of 3. Well, they give us the function f right there. Okay, and what this is saying, you're going to stick the number 3 into this x and come out with an answer. So again, f of 3 is, you put in 3 for x, work it out, and you get this. Okay, f of -5, again, we put a -5 into that x right there, work it out. You see that the -5 doesn't change on this side, the 3 doesn't change. This says I put in the number 3, the answer was 10. I put in the number -5, the answer was -6. Okay, I can do that for all of these. Okay, f of 3 halves. Again, f of 3 halves, I write that down. Okay, it says 2 f of 3 halves plus 4, and you can go ahead and write f of 3 halves here. And that should be written the same thing down all the time. Okay, now this one, it's a little tricky. It's got a 2 out in front of here, f of 3. So the first thing we're going to do, we're just going to block that 2 out for a second. Work f of 3. Okay, it says f of 3. I stick in 3 for f, 3 for the x in the f function right there. Work it out, and I get the answer of 10. Well, finally, once I get the answer, it says, well, then I multiply whatever I got for f of 3 times the number 2, and I get 20. Okay, now this one right here. Okay, instead of just putting in a variable, I'm going to put an x minus 5 into the x variable, or substitute x with x minus 5 into the f function, and then whatever I get after that, I'm going to multiply everything by -3. Okay, so again, that's your f function right there. Okay, I'm going to stick in x minus 5 into that, so I've written right there. Simplify as much as I can. Now that I can't do anything else, go ahead and multiply everything by -3, and I get that. So -3 f of x minus 5 is equal to -6 plus 18. Okay. Given a set of ordered pairs, fine. We're going to state if it's a function or a relation. Okay, and again, we check it out. Do I have the same x value input twice? Oh yes, I do. I've got a 4 and a 4 again. The first time I put in 4, I got a 7. The second time I got to put in a 4, I got a -5. Obviously, I cannot have 2 different y values for one, or two different outputs for one input. Okay, so this is a relation. Now, if I ask you guys to find the inverse of a set of ordered pairs, it's super easy. All you do is just flip them around. Switch x and y, switch x and y, switch x and y. So 4, 7 becomes 7, 4. 3, -1 becomes -1, 3. 4 negative 5 becomes negative 5, 4. Okay? Now again, I check to see if our inverse is a function. Do I have the same input value twice? No. Okay? So that therefore it's automatically a function. Okay. Now, a couple of steps to finding the inverse. First step, simply switch x and y variables in the equation, then go ahead and solve for y. Finally, replace y with the notation, function notation f of negative 1. That negative 1 stands for inverse of x. Okay? So here's the first problem right there. Okay? I rewrite the equation, simply switching x and y. Put x for y right there. Okay? I minus 10 on both sides, and finally divide by 2. I get this answer right here. Okay? And I replace the y with the denotation f of inverse of x. Okay? And I can go ahead and leave it like this, or I can get a little bit more simple and divide by 2, and get that. Okay? Let's try this one. Again, switch x and y first. Okay? Now I go ahead and solve for y. First thing I do is I multiply 4 on both sides. Then I minus 1, and then divide by 3. Okay? So, and then that's all what y equals. And again, I replace y with the notation f of the f inverse of x. Okay? We can leave it like that, or I can rewrite it with 3 dividing into both the 4 and the negative 1. Okay? Next one, switch x and y. Well, there's nothing else to solve for. So this is x equals 5. And remember from our rules of linear equations, okay, this is the equation for a vertical line at 5. So you can say the inverse of f of inverse is 5. And this is not a function, okay, because simply a vertical line. And vertical line would obviously fail the vertical line test, and this would not be considered a function. Okay? Again, for this part right here, switch x and y. Okay? I'm going to go ahead and minus 3 on both sides, divide by negative 2. Okay, so I get y squared equals x minus 3 divided by negative 2, and finally take the square root of both sides to get rid of that exponent right there, and I get this. Okay, y equals that. Again, obviously, plus and minus. Okay, and then change that to change the y to f inverse of x. Okay? Now your homework is right here. We're going to be doing this stuff in class, so I hope you guys have understood this well. Make sure you take the notes and watch the video a couple of times. Okay, take care, and I hope to see you in class tomorrow. Bye.